Uh, Good afternoon. So we are now going to proceed with our paper which was written in 2024, the last question on functions, which is question 6. So you are given in the diagram below the graph of fx. Here's the graph of x. Here's the graph of fx, which is equal to negative x squared plus 4x plus 5. And g, a straight line, are drawn. C, which is a 0.38, is a point of intersection of F and G. EH is parallel to the y-axis with E a point on F and H a point on G. Then here's our graph. So the first question is calculate the coordinates of B, the turning point of F. So question 6.1, we want the turning point. Okay. Want the turning point. So if our equation is given in the form y is equal to ax squared plus bx plus c, like the form which is given there, we know that our x at turning point, our x value as turning point will be given by minus b over 2a. So it means our x here will be equal to minus the b is the coefficient of x, which is 4 over 2a. Our a in this case is negative 1, which is the coefficient of x squared. We would see that this is going to result to a 2, trusting the calculator. Then we now want the y value because the question wants the coordinates. The question wants the coordinates. So to get the y value, it means we are now going to say our y must be equal to, we are substituting in this equation. So our y will be equal to, where there is x, we are going to put a 2 squared minus, it's plus 4, then we put a 2, then we put a plus 5. So the final answer here is going to give us, if you trust your calculator here, it's going to give us a 9. So this is 2, 9. It means these are the coordinates of B, which is the turning point there. But alternatively, for any function that can be given, to calculate the coordinates at turning point, we have to first get the first derivative of the given function. So if we derive that function, it means here we have our negative 1, then we bring our first derivative, which is defined by f prime there. It means here we are having our negative 1 for our first term, which is going to multiply by the power, which is 2. We are applying the rules, then which is going to be applied by 2. Sorry, by x to the power 2 minus 1. So here it's going to give us minus 2x. When it's a linear term, for x, we just take the constant. In other words, we are saying the coefficient there for that second term is 4. Then the power is 1 multiplied by x to the power 1 minus 1. We know 1 minus 1 is 0. Any number raised to the power 0 is 1. 1 times 1 times. So we are going to get plus 4. This becomes our derivative. When we differentiate a constant, we get 0. So once you differentiate, you have to know that at turning point, the derivative will be equal to 0. So minus 2x plus 4 is equal to 0. Transpose this one to this side. You are left with a negative 2x being equal to a negative 4. Then divide both sides by a negative 2. Divide both sides by -2. It means our x is equal to 2. Once we get the x equal to 2, we are going to come and substitute in the original, that x value in the original function, meaning to say we have to put a 2 here. We have to put a 2 here where there is another x there. So it will be -2 squared plus 4. We'll realize that you get the same set of coordinates. Then, if we are to check the second question, is saying so that the equation of the line through A and C is given by this is C, this is A. So to get the equation of the line, we are going to need the coordinates of A so that we will be able to calculate gradient. If we check this A, is the intercept, x-intercept of both graphs, which is F and G. So we are going to get the x-intercepts of our F. So we know that on question 6.2, we need x-intercept, and we know at x-intercept, y must be equal to 0. It's either we get x-intercept, which is this point, or you get y-intercept. So we are just going to do both. So let's first do the x-intercept. Get intercept y equal to 0. So we are going to substitute 0 equal to minus x squared plus 4x plus 5. So we now have a quadratic equation here. This one is x squared. So it means the x is equal to minus b, copying the quadratic formula from the formula sheet so that we don't make mistakes, plus or minus b squared minus 4ac all over 2a. So when you substitute, the x will be equal to minus the b, it's 4, plus or minus the square root of b squared, so it's gonna be 4 squared minus 4a, it's -1, which is the coefficient of x squared, and the c is a 5 all over 2, the a, it's a -1. So if we are to check here, it means your x gonna be equal to -6. -6, you get -10 divided by -2. So the x gonna be equal to 5, or the x gonna be equal to, here we get 2, -4 plus 6, which is 2, 2 divided by a -2, which becomes a -1. So if we check the coordinate there, it's -1. Then we now want the y coordinate. We said it's 0 there. So using those coordinates of A, so we are saying the coordinates of A are -1, 0, and the coordinates of C are 3, 8. We can use this to determine the equation of the line. So it's going to be what? So to get the equation, we need the gradient. We use this to calculate gradient. Copy the gradient formula from the formula sheet. So it's gonna be gradient is equal to y2 minus y1 over x2 minus x1. So this becomes, if we choose this one to represent y2 and x2, and this one y1, and it becomes 8 minus 0 over 3 minus 1. If we check we are getting, we use a calculator, we are getting an answer of 2 as our gradient. So the equation y is equal to m, the gradient we are saying 2x plus c. Then from the points that we used, we choose any point that we want. We can even use the second one. So it will be 0 equal to, we can use this point A that we calculated, equal to 2x but our x is -1 there plus c. So 0 equal to -2 plus c. When you transpose, the c is equal to 2. Therefore, the equation is given by y is equal to 2x plus 2. This becomes the equation. Or instead of getting the x-intercept here, the method that we used here, it was possible that we get the y-intercept here. Or it was not possible. It means we needed the x-intercept. These are the only coordinates that we can get, because here we cannot get them because we don't know the equation of this curve. But here we were using them because it's a common x-intercept between these two graphs. Then from there, it means we needed to do the next question, 6.3. It's saying calculate the maximum length of EH for which F is greater than G. So if we are to check, we want the part where F is greater than G. That is the first part that we are going to concentrate on, where F is greater than G. That distance, so we are going to say F minus G to obtain that distance. That is question 6.3. So our F is going to, it's what? Our F is negative x squared plus 4x plus 5 minus G. In other words, that is the general distance of EH. What's G? G is 2x plus 2. Then make sure we put bracket when you subtract the G. So it's gonna be equal to minus x squared plus 4x plus 5 minus 2x minus 2 when this negative multiplies this bracket. So this becomes minus x squared. This one and this one, they are like terms. So plus 4x minus 2x, we get plus 2x. Then plus 5 minus 2, we get 3. This is the distance of EH in terms of x. But here they are now talking of the maximum. The maximum, the moment we see maximum, it means we have to differentiate this distance. So it's EH prime. That will be equal to negative. Then you bring down the 2. We get x to the power 2 minus 1, which gives us 1. Then plus 2. And we have to know that at maximum, this derivative, which is said EH prime, this derivative must be equal to 0 at maximum. So minus 2x plus 2 equal to 0. Where is it equal to 0? It's at maximum. At maximum. So if we solve that, we are going to have the negative 2x being equal to negative 2. So it means the x here is equal to 1 after dividing both sides by negative 2. Therefore, the maximum value of EH, we can only get it after substituting 1 here. So it will be equal to negative 1 squared plus 2, then 1 plus 3. So when you simplify this, we are going to get a negative 1 plus 2 is 1, 1 plus 3. So the maximum distance is 4 units. Yeah, it's gonna be 4 units. Then the last part of the question is saying, given that Kx is equal to Fx plus m, which will be equal to minus x squared minus 2mx minus m squared plus 4x plus 4m plus 5. Then the question is saying determine the value of m for which g is a tangent to k. So we have to take k, we write it in standard form. So where x is squared, we have only that term. So we are going to have x squared. Then we take the terms with x. So it's gonna be plus 4x minus 2mx, then we take the constants, we're gonna be having plus, let me write minus, we check these ones are the terms with x, then these ones are the terms which are constants, terms without x. So minus m squared plus 4m plus 5. So this term that we wrote here is our k, then must be equal to g. Our g gonna be 2x plus 2. So let us write this equation in standard form. So we are going to have x squared plus, then we take this 4x, we take this 2x to be here. So when it crosses, it's going to be negative. So 4x minus 2x, we are going to get plus 2x minus 2mx, then minus m squared plus 4m. We take this 2, which is a constant, bring it here, becomes plus 5 minus 2, so it becomes plus 3 equal to 0. So in this case, we are going to identify our terms. So a is the coefficient of x squared. So our a will be equal to 1. Then b is the coefficient of x, which is going to be 2. Then minus 2m. This part, the coefficient of x. Then the constant, which is c, that one gonna be minus m squared plus 4m plus 3. Then we go back to the question. The question is saying, determine the values of m for which g is a tangent to k. If g is a tangent to k, it means these are going to only touch at one point. They are only going to touch k and g are going to touch at one point, meaning to say there will only be one solution to this equation here. And if you check, this equation is quadratic, and one solution can only happen if the discriminant is equal to 0, which is b squared minus 4ac is equal to 0. So let's substitute here. Our b is 2 minus 2m. So b squared minus 4. The a is 1. Then the c is going to give minus m squared plus 4m plus 3. there, then equal to 0. If we are to solve the question expanding this, we are going to get 4. After squaring this, then this times this, we get minus 4m times that, we get minus 8m. Then we are going to have plus 4m squared. Then minus 4 times 1 is minus 4. Then that one is gonna be plus 4m squared. Then from there, it's gonna be minus 16m. This one and this one is gonna be minus 12, being equal to 0. If we simplify, let's write this in standard form. This one and this one are like terms. They are going to give us 4 plus 4, they are going to give us 8m squared. Then we are going to have minus 8m, this one, minus 16m is gonna give us minus 24m. Then we have a 4 with a 12. We are going to have a 4 with a negative 12, which gives us negative 8 must be equal to 0. Simplifying this, we can divide throughout by 8. So it means m squared minus 3m plus, sorry, it's minus 3m minus 1 is giving us a 0. Then trying to solve that, we are going to use the quadratic formula. Right. Kindly take note that we had made a mistake. Here is supposed to be a negative here, as given here. Meaning to say here is supposed to be a negative there. So our A is supposed to be a negative 1 there. Kindly take note of that. It's supposed to be a negative 1. Let me just record using a different color. So here we are saying we had made a mistake. Here is supposed to be a negative here. So here it's a negative there. So our A must be a negative 1 there, as it is given there. Then here, when you substitute for A there, it's supposed to be a negative 1 there. So it means here we are supposed to have a, if we check this and this, it's gonna be a negative, positive. Then it was supposed to be here, take note. It's supposed to be a negative, because we are saying negative 4 times negative 1 is positive 4 times a negative m squared is supposed to be a negative 4m squared. Then we are having negative, negative is positive times a positive there. Here we are supposed to have a positive 16. Here we are supposed to have a positive 16. Then here a negative which is there. A negative which is there. Take note there of that negative. So when you have positive here, it means here was supposed to be a positive, not a negative. Then when you simplify, here take note, we are going to have this and this are like terms, but it's 4m squared minus 4m squared. So this one becomes a 0. This one becomes a 0. Then here we are going to have a negative 4m plus a 16m. This is going to give us a negative 8m. We are referring to this part which are having stars plus 16m. Can we please take note here? This part. So this one with m, we are supposed to have a positive 8m. Then this 4 plus that 12, we are supposed to have a positive 16. That will be equated to 0. Take note here, we had made mistake of the sign. Then from there, we can solve this equation here. We are left with the equation which is saying 8m plus 16 is equal to 0. Then transposing this one to this side, your 8m is equal to a negative 16. If you divide both sides by 8 here, it means your m will be equal to a negative 2. So, for G to be a tangent to K, it means the m must be a negative 2.